about that. Today we're going to go through some of the basics of Elasticsearch, explain some of its application interfaces, especially for PHP since that's Drupal's core language, and then we're going to talk about a few use cases that we've had on our own projects. Go to the next slide. Actually, is that working? So we're going to start with what Elasticsearch actually is. If you go to the next one, please. Elasticsearch is a distributed JSON-based search and analytics engine designed for horizontal scalability, maximum reliability, and easy management, which basically means that it's a search engine. It uses JSON as its backend sorry, I'm a little nervous for some reason. This is not normally the case, but it uses JSON as its communication language so that you can pull that into all of your products. And it has a really nice engine built into it for full text search. Some of its features is that it's an open source piece of software, so you can get in and modify it yourself if you're so inclined and happen to know Java, which is what it's based on. So it can run on anything that can use Java, so basically it is completely multi-platform. It uses Apache Lucene as its backend, which is a full text search device. It has a near real-time latency, which means that it takes only about a second or so to actually return results. It very rarely goes slower than that. And then because of the way that it uses clusters and nodes, it is theoretically infinitely scalable. So a bunch of people now use this. We've got some of the big players up here: eBay, Netflix, Dell, NASA, Facebook. A lot of people use Elasticsearch because it's extremely flexible and powerful and has a lot of really nice features, and we'll go over a few of them today. So first we're going to talk a little bit about how Elasticsearch is put together. This is going to be fairly high level, but it is going to be using some technical terms, so just be aware. So the basic unit in an Elasticsearch cluster is a document. So the best way to explain this in terms for a Drupal crowd is you can think of a document similar to a node in Drupal. It's just a collection of data that you're intending to use as a display. It's expressed in Elasticsearch as a JSON document, so it's really easily portable because it's kind of the standard language for the web for transferring data nowadays. Each document has a type, and this is basically just a logical category that you can put things in. So you can have a type for shirts, and a type for pants, and a type for this product or that product or this node or that node. And it's pretty arbitrary how you can do that. But it allows you to leverage a lot of categorical abilities, which is really nice. And you can have multiple types per index, and an index is a collection of documents. And so you can think about this as sort of like your database structure, though it's not a database. Maybe I shouldn't have used that. It's just a group of similar documents. You can have as many documents as you want in an index, and you can have an unlimited amount of indexes in a node, and a node is a server. Don't worry, I'll backtrack and walk you through this in a second. A node is a server, and you can have servers collected into a cluster, which means that you can spread Elasticsearch across many storage backends, and you can spread a lot of data across a huge set of connected nodes, which basically means you have an infinite amount of scalability just by connecting a lot of storages together. So to recap, a document has a type, it's in an index, and the index is in a node, and nodes are part of a cluster. It's really kind of all you need to know about how things work in terms of its organization. One feature that it has, that Elasticsearch has, is called sharding. Sharding basically allows you to divide your data into sets that can then back each other up, essentially. So there's two kinds of major shards. The first kind, the normal kind of shard, basically splits your data into several places, so you can set versions of it across multiple servers, which makes your latency a lot lower, because you can, when you ping Elasticsearch for some data, it can search several shards at once. And so it's not just going through one index line by line, it's actually looking at several shards all at the same time, which makes it go a lot quicker. And it allows you to parallelize things. So one kind of shard that's really useful is called a replica. And basically, when you shard out an index, when you create several shards of it, it takes that primary and makes a duplicate of it, so that if any one of your shards goes down at any time, it still has all of the data. So Elasticsearch is designed so that if you have some sort of server or application failure that makes part of it go down, everything is still available. You have to do quite a lot of damage to Elasticsearch before it actually stops becoming usable. So it's also a schema-less engine, and part of what makes this really useful is that when you are putting data into Elasticsearch, it can on the fly decide what it is. And it makes a rather good best guess. So if you send it a bunch of numbers, it'll figure out that those are integers. If you send it a bunch of dates, it'll know that they're dates, and it'll be able to organize itself without you actually having to set up a schema, similar to something like you might do with a database. You'll have to define what your columns and rows are, and with Elasticsearch, you don't have to do that. However, it's not a perfect engine, so every so often it won't get it quite right. And the upside to that is that you can define mappings if you wish on your own. So if you do want to set up a schema, you're more than welcome to do so. One of the things that this means, though, is that Elasticsearch is not designed to be a document store because it's not mutable, or it's not immutable. It is a search engine. The title is, for search. That's its tagline. But you can obviously use it however you wish. Please ignore the winky face. I regret it. Another powerful feature that Elasticsearch has is aggregations. And this is maybe where a lot of the most effective search power comes from. Aggregations basically allow you to, on the fly, at runtime, create logical organizations for the data that you have. And so you can basically split it into different kinds of buckets and get different pieces of data out of it that you can then control. There are 4 major categories of aggregations that Elasticsearch provides. The first is probably the most common. It's called bucketing, and basically it allows you to determine categories for different pieces of data based on basically any kind of query that you want to do. If you want to organize things by the first letter of the string, you can theoretically do that. It allows you to create completely arbitrary and unlimited buckets. One of the best parts about bucketing is that you can actually make buckets of buckets of buckets of buckets if you really need to. And so if you need that kind of deep, nested categorization, you can fairly easily do that. Another kind is metrics. That allows you to keep track of things like document count and really basic metrics about things. It also allows you to do kind of deep analytics. The third kind of aggregation, they're called matrix, and they tend to work with metrics together. It is experimental, and Elasticsearch doesn't have any clarity on whether or not they're going to be kept, but allows you to use the data in your document fields to do statistical analysis on things. Analysis on things, and keep track of a lot of really deep metadata and understanding about the data structure that you have. And then the last is pipeline, which I said before is basically your buckets of buckets that allows you to aggregate aggregations, essentially. That allows you to do a lot of really interesting things. One example that I've heard that's really useful is that if you're doing a search, let's say you're a clothing store, and you're doing a search on red shirts, for your search display, you can keep track of the facets of other kinds of shirts. So if you want to look for red search, when you ping the server, you get back all the red shirts that you have, but you can also aggregate data from other kinds of shirts, so you can keep track of their count. So if you look at red shirts, you can still see on green there's 30, or on yellow there's 14, and so you can still keep track of all the other stuff that you're not actually searching on, which is really nice. So we're going to talk a little bit about actually how to interact with it. We're going to primarily be using, if you want to go ahead and go to the next.
Can I just ask a question?
Yeah, go for it.
It sounds like from your description, I could totally see how it'd be good for catalogs, right? Which is effectively what Amazon is.
Yeah.
But the only thing you really mentioned, what about just sort of random collections of documents? Because full text indexing isn't all that great. I mean, that's like what any search engine can do.
Right. So can you actually ask that again more?
My question is just, it seems, I can totally understand how it would be great for catalogs. Things that have categories of stuff.
Sure.
Right, that's the easiest stuff to search in the world.
Uh-huh.
How does it do well with random, not very well defined documents?
So my understanding is that it actually does pretty well. Elasticsearch is able to make a lot of assumptions about what your data actually is, and provides a lot of logical groupings for them kind of on the fly, because it is able to figure out what kinds of data the fields that are coming in are, like how they're supposed to be organized. Some of that you have to define on your own just as normal, because even if it's random, you're going to have to impose some structure on it. But Elasticsearch doesn't care what you put in it. It'll just figure it out and store it. So you don't have to worry about it being super structured at a time. That's the advantage of it being schemaless. Does that answer your question?
So so I suspect it would be interesting to see what it, how it tries to categorize it and bucket it.
Yeah, I think it largely works. We've just fed stuff before, just things that don't really have a lot of relationship to each other, and we're able to return them and figure out and actually do aggregations and stuff fairly easily. As long as there's any kind of similarity, you can operate on it.
Okay, thank you.
No problem. All right. Application interface. We're going to primarily, in these examples, be using the Elasticsearch PHP appliance. You normally can operate against this. It's with a curl request if you're using some other language or want to operate it more directly. Elasticsearch does use a fully RESTful API. So basically, that just means you're pinging a URL. And it's pretty simple. It accepts get, post, put, head, and delete, so all the major pieces of interacting with a server. And there are two major ways that you can work with this if you're not using the PHP module. You can use a URI request, which basically you're going to put localhost 9200. 9200 is the default port for Elasticsearch, and you'll say /index name, so Drupal/node /1, and then you'll get that back. You'll get node 1 back, whatever node 1 is in your particular instance. So that's the most simple way to work on it. And then there's also the request body, which you'll pass in a body, which is essentially a JSON piece that you're going to be sending back. And we'll look at some of that, but we're going to be using the PHP interface, so you're not actually going to see how that curl request works. It's all in arrays there. There are two major ways to play with Elasticsearch. If you want to go home and mess with it, you can install it on your local machine, and whatever setup you have, you just go to localhost 9200. Also, there is a really nice application that I'm not going to be talking about at all today that you should totally check out called Kibana, which is free. It's a module that sits on top of Elasticsearch. You can use their dev tools, which is in the Kibana interface, to do all kinds of fun stuff with Elasticsearch. Go ahead and go to the next thing. So if you're going to get started in your Drupal project, the easiest way to install it is to use Composer. And you can just run this. You can just add this line once you've pulled it down to your application, and it should all be available to you. Yeah, I've already explained this. I jumped ahead of myself. Elasticsearch PHP is the library that we're going to be working. It's a very low-level interface. It doesn't assume very much at all of what you want to do, which means there's not a whole lot of convenience stuff in there. There's a few exceptions, but not much. It's going to be straight up whatever you write. It very closely matches the standard that Elasticsearch uses in its curl request. Everything is encapsulated in an associative array, which is what you'll see. And so if you're working in Drupal, it should be pretty familiar. And it's designed to be built on top of. We'll actually talk about a module that is built on top of it toward the end of my part of this talk. So the basic command for creating a new index, which again is a collection of documents, is very simple. You just set up your parameters. You'll need to pass in an index, whatever your index name is, which I didn't make that a string, which is embarrassing. Sorry, I should have. And then you'll pass in a body. So for creating an index, you'll want to determine how many shards and replicas you have. Now, I mentioned this before. Sharding is how you divide your data across a node. And then replicas actually are your failover devices primarily. You don't have to define either of them. If you don't define either of them, it'll default to 5 shards and 1 replica. And then at the bottom, you have a fairly simple interface. It's just client, and then, so whatever client is, so I set up, what I didn't show you is instantiating Elasticsearch as client. Then you pass it indices and create, and it'll make your new index for you. If this is too low level, let me know, and I'll try to back up a bit. So when you're adding new content, it all kind of works very similarly. You have to pass in an index, a type. So you always have to define a type when you're creating a new document. A lot of times, I think, I'm actually not going to say that because I don't want you to quote me on it. You have to define a type each time you're adding new pieces of content to it. And then you can also specify an ID. If you don't specify an ID, Elasticsearch will figure it out for you. And then you're going to pass it a body, like before, with whatever fields you want. In this case, we're just creating a happy little page. Yeah, I did talk about that already. Okay, so if you want to modify content, there are 2 ways of doing this. There's merging and there's scripting. So there's a way in which that you can pass back to Elasticsearch, and it'll kind of figure out how it's supposed to build itself. I believe this is part of a feature of Elasticsearch PHP. And so if you want to simply just merge new content or change content in a particular document, you pass it the index and type like normal. You also need to pass an ID, so you'll have to figure that out ahead of time. That's on you. And then if you'll need to pass in the doc parameter, that's the really important part. So body, doc, and then your fields. And that way, if it sees a field that you've already defined, it'll overwrite it or modify it in whatever way you want. Also, the other piece is, oh man, that's sad. That didn't work out. Is scripting. So scripting is something I'm not going to talk a whole lot about here, but this is actually one of maybe the most powerful features of Elasticsearch. It has a full scripting language built into it. It's called Painless, which is, I think, kind of a funny name. And it allows you to do all kinds of logical operations on your data. In this case, we're going to do something very simple, just to sort of show it off. You'll create things the same way. In your body, you'll provide a script. In this case, we're doing ctx source.counter. CTX is your document. Source is the data in that document, and counter is the field that we're operating on, and we're just going to add 1 to it. Or in this case, we're adding count to it, which the parameter is 1. You also have to define your language and the parameters that you're passing. The last thing that we're going to show on this is that it's fairly easy to remove content. If you want to remove something by an ID, you just pass it the normal data with its ID, and also pass the delete. If you want to delete the whole index, all you have to do is define what index you're deleting. This also means that it's very easy to destroy stuff, so be careful. I've done that before, by the way. Not fun. So maybe the most important part of Elasticsearch, the reason maybe why you're here, is its search query. It's extremely robust, very easy to use, very easy to get wrong, but also very easy to use. Thank you for laughing. We're counting on you for that. So you can take a lot of different forms of it. I mentioned before, you can do it as a very simple URI request or something more deep. There's also a lot of different kinds of searches you can do. There's the standard text search like I mentioned. You can also operate on it using term queries, which basically can use the fields to do operations. You can do nested queries, as well as do call queries within queries, and call data that's nested within itself. Elasticsearch, just as by the way, doesn't actually officially support nested data because Apache Lucene has no concept of nesting, but Elasticsearch does have a really nice interface for sort of faking nested work, so that you can actually still use your nested data when you put it in. And then also geo-queries, which are really important. Elasticsearch has a very robust ability to operate on GIS data. When you do a search, you can cover as many indexes as you want. So where in one case you might have to do like a lot of joins to get 2 databases to work together, Elasticsearch doesn't generally have to do that. As long as the data is in some capacity consistent across indexes, it's rather easy to operate on. And even if it's not consistent, you can still do it. So you can go across multiple indexes, multiple types. You can also use a post filter, which is super nice. This is for free. This is not really part of the core. Post filters, though, are really important because it means that you can query data and then filter it after it's been queried, which means that you do that in the request, so you don't have to write an interface in PHP to do that for you. It's just super good, and we've used it a couple of times, which is why I mention it. Elasticsearch also has a really robust scoring system for relevancy data, and so when you can set that scoring on the fly if you wish. You can boost things. You can make things more important than others. So if you have like one data source that's more important than the others, you can give it a better score when you're actually pulling things back, and do a lot of really nice relevancy manipulation, as well as the built-in relevancy tends to be rather good. So then we're going to go back to a little bit of code. A normal query, all these queries just use client search. A normal query looks very similar to it did before. It's just passing it the indexes that you want. And then you use query, and then match, and then whatever fields you're trying to match. You can also just do, you can also just do a match all, so if you wanted to get everything. And you don't have to, it can be any data that you have. It doesn't have to, it doesn't care. It will pull back anything that you search. This is really very basic. There are a lot of tools built into Elasticsearch for this, and the Elasticsearch PHP module really allows you to leverage basically all of them. I haven't seen what it hasn't at this point. Another kind of query that we'll look at is filtering. So you can use the bool function in order to filter on various terms and different things that are in your data. This allows you to do very obvious things like facets and controlling what data gets displayed on your searches. The last thing I'll show you in terms of code is this is kind of what it returns. It'll send back data that's like the index names that you have, how many shards you're using, that sort of thing. But the really important piece, mostly, that you'll want to operate on for Drupal is this hits section. And it's a little confusing because it's hits and then hits, which I don't know why they did it that way, but it'll tell you how many you have, what your scores are, and then it'll give you data about each individual document that you can return. It's fairly intuitive to use once you've seen it. I just wanted to show it to you. I wasn't going to go into too much detail though. Next up. All right, so the last piece of my part of this is going to talk about Elasticsearch and Drupal and what things are comparative there. Go to the next one. So most of you probably know that Drupal search is not awesome. I said that earlier and got a lot of laughter, so I'm not surprised. It's not very good. The two major things that it's missing that we've identified is that it has basically no sense of fuzziness whatsoever. So whatever you type in is what's going to come back. And there's no real way to do faceted search without building a pretty big appliance for it. In Elasticsearch, it uses a thing called the Levenstein edit distance, which is a really fancy name for, it determines how many characters need to change for one string to be another string, which means that you can set up a fuzziness in Elasticsearch of up to 2 characters. If you try to do more than 2 characters, basically you slow everything down really badly, and so they don't really let you do anymore. And so that gives you the ability, if like typos are made, so if like 2 letters are wrong in a search query, it'll still get it right, which is super nice. The secondary, and then also with facets, Elasticsearch, as I've mentioned already, has a lot of ability to do that. And Drupal's built-in search also doesn't really have any relativism scoring that's that good. Elasticsearch allows you to do a lot of that. So one of the ways that the community has already contributed to this is they've created the Elasticsearch connector module. This is just one of a few. None of them are super well developed yet. This is the most well developed one we found. And it's pretty simple to use. It's not exactly a plug-and-play solution. You still have to operate on it, but it works really well. It's a suite of modules that allow you to use Elasticsearch in your entire Drupal ecosystem, not even just your search engine. And it can obviously act as a replacement for search, but it allows you to do things like push watchdog messages into Elasticsearch and be able to do analytics on what your site is doing, however it's failing or working or whatever things you're pushing to logs. It does have a views iteration. It has this really nice content statistic module, which allows you to do statistical analysis on your Drupal data, which is super cool. And it does work for both Drupal. There is modules for both Drupal 7 and 8. Its limitations, however, as I mentioned before, is it's not well developed. It only has one release candidate, and that's for Drupal 7, and it's actually still in alpha. And the Drupal 8 module actually doesn't currently work. It's being worked on. The other piece of that is that the release version only works for Elasticsearch 1.0, but they do have development versions for 2 and 5 that I understand do work to some degree. Great. All right, so that's an overview. If you have any questions afterward, I'll be happy to try to answer them, but I'm going to pass it off to my friend Sean here, and he's going to talk about how we've used this on our projects.
Okay. I am not as confident as Jacob. I'm going to hide behind the podium.
Okay, do you want to just do your own then?
Yeah.
Okay, that sounds good.
Plus, I need my notes. I'm unprepared, so.
Yeah.
Okay. So that's nice and all, but where is it actually used in our organization? First example here we have is NASA Science. That's I can't see the slides. That's awful.
You have it right there.
Yeah, but it's so tiny. Anyway, so this actually, I believe, integrates with the Drupal module to do their node store. So it uses it indexes 4,000 unique pieces of content over a dozen different types of content types. It weighs the results based on the fields, and I think the coolest part is they actually use like a stop list for their searches to prevent like terms you wouldn't want in your searches, and it's predefined by a content editor. I'm not nervous at all, so the shakes, just ignore those. They're not real. Okay, so I guess this is my favorite one because I worked on this like most recent. Is the USGA store, aka USGS, but
we're trying to get USGA started.
Yes, it's going to be a thing. All right, well, it's a match, right? It's fun. So let's just go over the basics here. We've got USGS store, nice and pretty. It keeps a common theme across all the sites. So the main and the store, they have a similar theme. And a little fun fact for you is that header is actually the same. We actually just pull it in and copy it from the main site and copy it. That way it keeps the links consistent.
Sorry, I should shut up.
Okay, so
Cool. You're right.
all right. So the best part about this whole process was the use of SAP. If you don't know what SAP is, it is a complete platform for everything corporate. Their previous system, I think it's current system, they use SAP for their backend. It manages 230,000-ish products, all their customer information, shipping details, purchasing, and the best part about it is that it's PCI compliant, so we don't have to deal with credit cards. SAP does it all. The previous system also, when ingesting it, I guess I kind of should touch on that a little further, but they use bi-weekly ingestion of their products from their private to the public, and it took about 9 hours bi-weekly. Okay, so why did we choose Elasticsearch for this? We had specific query needs, like specific faceted query needs that can be pretty heavy. You got the autocomplete functionality, the keyword, the index aliases. Did you have those? I don't think you did.
No, I didn't.
And then you have geo queries, which I guess, Gus, it's geological, so you kind of need those. And why Elasticsearch? Because Digby. Drupal is great, but
Nice.
Thank you. All right, and so we wanted to prevent the bloat in Drupal. Because of all the products we're actually indexing, we didn't want to have to manage the taxonomies, and every time we ingest, have to update those and find those and parse those out. And Elasticsearch can support that, as previously discussed by Jacob there. Basically, the data comes in, we clean it up, and then we ship it off, and our app servers are free to do whatever they want to do, so process commerce orders. The other, the main benefit, I would say, are the aliases. This allows us to in-place upgrade the database. So what happens is we have a nightly cron script that will actually fetch the data, parse it, put it in a separate alias, and then upload the alias. And then after it's finished, it will switch over the alias, and the user is none the wiser. Okay, so ingestion. The bad. SAP has really no method to get only the updated products. We had to essentially query everything and download the whole database because we have no API just to get only the updated. We also have a legacy field structure that we can't touch, we can't control, and I'll touch more on that later. We have, so you're saying, how do I phrase that better? I'm totally, again, not nervous, so this is all fine. Yeah, products updated, blah. We could have set up a REST adapter for Drupal probably to actually say, hey, I updated this product. So on the SAP server, if they say something, we could have made a REST API, but the complexity in the field structure didn't allow that. Yeah. Okay, actually, I'm going to go back on that. The good, it is PCI compliant, and we have JSON, which is great. Yeah. Okay, so this is my pride here. I'm really happy with this chart. It's a little cluttered, I know. So you guys are good on that? Okay, perfect. We're going to move on. Okay, so basically what's happening here, we have our nightly cron, and from there, it fetches our product IDs. And the product IDs are actually stored on a network share. And from there, once we fetch product IDs, we go ahead and create a new index in Elasticsearch. And then with those new product IDs, we start parsing them because they come in a non-standard format. So it's actually having to abstract them all, which is, I love SAP. No bad words about SAP. So we parse those, and then we go ahead and we put them into a batch of 1,000. We fetch those batches, handle the response, and if we have failures, put those back in, pop them back up, and keep looping until we're good. Then we also like, so if it's good, go to the update progress variables, clean those products. Again, if they fail, they go up. If not, then we're good. This keeps running and running and running until we're out of IDs. And we do a sanity check as well to make sure that we have as many products as we should from the IDs, which another fun fact about SAP was that we got duplicate product IDs in the unique list.
That's fun.
All right, so once that's finished, then we go ahead, we verify, do sanity checks, and then we switch the alias. And then once everything's switched, we go ahead and pop off the oldest one, so we keep rolling it through. Okay, and here it is in normal words, not questions, comments, concerns on this. Silent, great. All right. So, our difficulty here was actually like parsing the products. Jacob mentioned like a dynamic index, but we chose not to do that because of reasons. And those reasons are, we wanted to prevent dynamic fields. As you can see there on the right there, it has like type keyword and type text. Type keyword will do like whole word queries, and type text will break it down for analysis. So in an example here, we wanted to pull back a list of terms. And in order to pull back a list of terms, full words, we had to actually use a keyword search because it won't break it up. It won't analyze it. Whereas the type text will actually break it out and be more search friendly. So in order to actually use this, you would just like, if you wanted to go off the abbreviation, you do abbrev. Yeah, this is in the nestled, never mind, disregard that. Okay, so here's the actual process of cleaning the products from the store. It's a little great, and again, I have no bad words to say about SAP. Okay, so remove the data, convert the property names, blah, 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 clean the geopoints, and let's actually see some fun things. So this here is one of the examples of the edge cases. Can anybody spot the problem here?
Out of lat long bound.
Yes. So why is that a problem for here? Because they have maps of Mars, which apparently does not fall into the category. Elasticsearch does not like this and throws an error. So we now search for the range. Okay, the next one here. My grandmother always told me 3 things. Always floss before going to bed. Never trust a single picture Tinder profile. And regex look ahead conditionals will get you out of a jam.
Exactly.
So here the problem was, you've got concatenated HTTP strings. It's almost as if someone was messing with me and they put multiple URLs for these in here. And they were a mixture between HTTP, HTTPS, and yes. Yeah, the rest is pretty much standard regex, but you can see the complexities and the different types, and it's fun. Again, SAP is my favorite. All right, this one here is fantastic because it allows the end user to actually store all their data however they want. They can separate dates with periods or slashes. I'll just think about it for a second. That's a joke.
Didn't work.
Yeah, I know. I'm moving on. We're good. We're moving past it.
Yeah.
So as you see there, I tried to handle both with some grace. Is it a slash? Okay, we'll separate it out by that. And you're wondering, why do we have to separate it out? Because they can also use month, day, year, or day, month, year. It's their preference.
Cool.
And so you see there, my solution to this was, okay, is the second parameter greater than 12? All right, it must be a month. Or it must be a day, sorry. And the reason this was important is because Elasticsearch, it would throw, whenever in the ingestion process, it would actually throw an error every time there was a bad date. It would actually rather accept null than a bad date because of the strict. And yeah. All right, so the previous iteration for ingestion, this is our first go about it. we experienced timeouts, and there's a little asterisk there. I'll get back to that. The Drush, like, we worked around this by making the Drush script actually be able to resume where it left off and save this huge cache and just come back in and try and gracefully handle the failures, right? The second problem we had was the Elasticsearch cluster would start to fail after about 78,000 documents. And then once we finally got those, it took about 4 hours to do. The first asterisk was my fault entirely. The database connection timeout threshold was a little low, and that took me a little too long to figure out. The second one, also again, my fault. We ran out of storage. You're thinking, 230,000 products, how big can that really be? It's a trap for young players, but GeoQueries actually store a lot more room, and expand to a lot more room than just a normal text query. So be advised. Let's see here. Just so always remember to check your logs and watch your disk size because time. All right, so we fixed the human errors. The proxy, the layer was like a proxy issue, and the storage capacity. And also, I want to reiterate on that. The storage was an issue because we have 3 simultaneous indexes going. So we have our 3, and then we import the 4th one. And then once that 4th one's imported, we go ahead and drop off the last one and keep going. So I think we originally had 10 gigs of storage, and with those 3 indexes, it was filling it up. We went ahead and cast the product. So the original request, actually, we had to make an HTTP request to the server, and it came back with a response of like a, this is the, oh yeah, final, okay. So yeah, the times are there on the right, I didn't touch on those. But it took 16 minutes to actually pull that in, and then the products took another 188 minutes to get, because we got that big ID list, and then we had to go and get each product. And then on top of that, we had to upload them to Elasticsearch. From there, we went ahead and the parsing of the ID tail takes about 4 seconds. The product's response, what we use is we use the Guzzle response, or the Guzzle HTTP library, and it will actually do 32 simultaneous requests instead of just the 1. And then how we upgraded the Elasticsearch part was we started doing batch inserting, and that got our total time down to 44 minutes. And if that wasn't good enough, we've got a handy chart here.
Wow. That's cool. Wow.
Okay, so so the dynamic the search aggregations. We have a lot of like filters and different things you can do for the filtering of the maps that we search for on the site, and this allowed us to hone in on those specific ones. We can query products based on geolocation. Jason Glisson, a coworker of ours, he wrote an interface for a map locator. Basically, you can drop a pin on a map, and it will try to find all the maps in that region. Which, spoiler alert, it does. We also want to do a completion suggester for partial queries. So if you weren't quite sure how to spell something, you can type out a few letters, and then you'll get back the results and, oh, it's this one, and then you just click on it. And I know this is all great, so let's actually see it. Okay, so here's an example of the actual filtering in the store cart. So I wanted to find a document from Parker, Oklahoma. Let's filter by Oklahoma. Oh, it's going a little fast, but it's too many, so I'm just going to go through it. So let's filter, then we got too many, so let's filter by typing in the word Parker. Okay, still too many. All right, let's make it a topographical map only. So here's Parker, and then we're going to make it topographical only. Perfect, the exact product I wanted. And here's an example of the geo queries. Oh yeah, Google, the Google one, it just starts. So we're just going to wait. Thank you, Google. Disregard this, close your eyes. Okay, so I don't remember how to spell Seattle. Oh, it told me how to spell Seattle. Perfect. Okay, so view the products. Then I see a range. 1909, that's way too early. Let's move it up a little bit. Okay, so I see a 73 now. I want newer ones only. And then now it's limiting the queries based on the date parameters. So it's using the geolocation plus an extra filter on top of it. Okay, so that's all fun and games. Where else is this used? It's currently being implemented for a little organization you guys might have heard of. And here, so the NASA.gov homepage is a little heavy, but because it has a lot of content. As you can see, you have different node types, and you have just a bunch going on. So it's high traffic, average of 1 million page views per day. Legend has it's been as high as 9 million in one single day. The Drupal side, we have a few feeds. We have latest and related, which like right here on the left-hand side, you have the latest and related tab, and those pull on like the latest, all the newest ones, and the related related to the one you're looking at. YouTube playlist, they implemented the API changeover, so we had to proxy all the playlists through the Drupal side. And the calendar events actually uses Drupal to manage those currently. We use static assets from S3 for security and reliability and security, because you can't really mess with the static file too much. Okay, so heavy is the browser that makes the requests. Here is one example of a page from the current .gov website. As you can see, it's making a request for the node we're on, and then it's getting a list of all the nodes for the next portion of it, because the autos like the scroll down. And then the next ones are tag results. So it's quite a few. Those are all stored on S3, but it still takes time to request all those. So our next implementation is going to, it already does. It's limited this without the tags down to 24 requests. And instead of using, I want to say, 800 kilobytes, it's now down to 60 kilobytes. I don't have a pretty graph for that, I'm sorry. Okay, so this is not related, but I figure it's pretty good to talk on. This is an example of how to actually use AWS with this, because it's kind of tricky and kind of hard to find. So here we're doing role-based authentication, and this is for say an app server, and it can do all the things. And in order to actually do this, since there's not really a good way, we use like a proxy, a Go proxy, for actually signing the requests and then pushing them off. And if you wanted to go for the more public side, we've limited it down to only GET queries. And the reason that is for cache and speed, because the cache server can make those requests and then save. And so it has like the index slash, so you have the main index, sample index, and then slash Uber node, which is our main content type, and a star. The star is because you have two different types. You can go with the slash search and do a search, or you can do slash an ID and actually get an ID from the index. And then here's an example post-config if you're brave. So the way Elasticsearch actually handles the data is with a post request, you can write stuff. So this will actually prevent writing. And we only allow on the search, so you can't actually, so your Uncle Cletus can't talk about how the world is actually a Mobius strip and carbon nanotubes are responsible for the polar bears melting. Okay, so here's an example of our, just one of the queries we're actually making. So it's kind of hard to read, so I kind of broke it down different lines. We're starting at 0. We're sorting by our event dates, so the newest ones. Sorting by our calendar. And we have an and, or, and. So we're going, I think this is for the actual like TV player, the little map there. It has the channels. And so we're trying to find ranges in between there. And the event date count 1, actually I want to touch on that. It's we're using a script inside of Elasticsearch to, we store an event, has all these different events stored in it, like a normal Drupal event would. And we take that, and then we break it into many different events for Elasticsearch, so we don't have to query and get all of it back. We can just get the one we want. And then this right here, the event date count 1, it prevents us getting that master date. It only gets the subsequent ones because it only has one event. Okay, so happy searching. That pretty much wraps it up for me. You can reach us at our booth or mobomo.com. We'd love to hear from you. Always, please don't forget to like, comment, subscribe.
So after this, we'll have everything. Just as an FYI, I failed and didn't have the slides uploaded yet. They will be up a little later today, Tom, just in for reference. Thank you guys for coming.
Thank you. Questions?
Yeah, go ahead.
Several. PDF indexing, is that a thing with us?
PDF, yes.
Okay.
Yeah.
That's good. We can talk later. I don't want to. I know that I have a bunch.
You have to
scrape it,
Oh,
Yeah.
scrape it.
but then you can toss it.
right,
Oh,
but there are
sorry.
tools to scrape it.
Yes, there are tools
Yes.
to scrape it.
Okay, so that's also another part of my question is for scraping external sites. So I guess you have to build a scraper and then you dump it into Elastic.
So actually, in terms of, this is something that we've done. We have some external sites that we needed to index into Elasticsearch, and we used Apache Nutch for that, which utilizes Apache Tika, which is how we can scrape PDFs. And so you can use that as a web crawler. It's actually something that we're doing pretty effectively at USGS.
And the last question for me, I promise. Relevancy based on which pages get the most clicks, is that a thing you can do?
You definitely can.
Yes.
We're not implementing it.
Yeah.
But it's definitely a thing.
I think the relevancy built into Elasticsearch has to do with content relationship, not with sort of like page use, but it is doable. You can set up an appliance that does it anyway.
Right. So I mean, if you were going to do that, you would have one of those filter queries. So you query, and then say your user data, you can also filter it with your user data to get more relevant results.
Yeah.
No, you mentioned several ways of talking to Elasticsearch.
Yes.
Like, how much of what you do is using the PHP library versus, guzzling your own requests versus trusting Elasticsearch connected to do it for you? Like, how much of your time is spent?
Since this is a Drupal convention, we do all of our requests.
No.
through Drupal.
So the reality is that it depends a lot on your implementation. And so if you're trying to do a pretty low level just search replacement, Elasticsearch Connector kind of can handle that on its own. You don't have to do a whole lot of finagling with it. But if you're doing something else, more along the lines of what we did, which is trying to build an index, especially of external sites, we are operating on it both through PHP and Python. And so with PHP, we're using that library, but with Python, we're actually querying through curl, well, not through curl, but through PHP, Python's requests module. And so it just depends a lot on the implementation that you have. The more basic you need, the more the module will just do the job for you. The more advanced options you need, the more you're going to have to write your own. But at least with PHP, if you're doing primarily in PHP, the Elasticsearch PHP library has access to everything, and so you don't really have to operate on it any other way. Make sense?
To add on to that, I actually wrote, if you guys like Ember.js, I wrote an adapter to actually handle Elasticsearch for us. So on the NASA side, it actually communicates with it directly, as well as Drupal. So we have public side and the private, uses like PHP to upload it, and then the public side only uses JavaScript to actually query it.
Where can they find that, Sean?
GitHub.
GitHub?
I will put a link in the slide.
Sounds good.
Yes.
Perfect.
All right.
First of all, really enjoyed the presentation.
Thanks.
Thank you.
A lot of good humor in there. Philosophical question. How did you, in your own hearts, come to embracing Elastic versus Solar or the next generic solution? And I'll put a little weight in there specifically about geospatial decision points.
Okay.
And then just high level, could you give us an idea of, from a resource perspective, to do your first release of the USGS store, just like what's a ballpark number in terms of people, hours that it took to make this successful? Because it's very cool what you've done. I think everybody struggles with reliable estimates and all the challenges. Like I love how you articulated your source systems, crap data, a lot of obstructions you had to deal with. But if you could just kind of touch upon that a little bit.
Okay, so I'll go first and talk about why we chose Elasticsearch. So very personally, I took an Elasticsearch training and loved it. So that was sort of how I got started. In terms of the reason why we chose it for our project, we're actually in the process of doing a lot more geodata right now ourselves. And so really what it came down to was a lot of our research pointed us to either Elasticsearch or MongoDB. So MongoDB, which is completely free, this is not part of the presentation, is a NoSQL data store. And it has built-in operations on GeoJSON, so it's very, very good for GeoSearch. Elasticsearch also has a lot of really powerful tools, but they're not as native. Like they work really well, but they're not as like sort of built into the core of what it is. We ended up deciding primarily to go with Elasticsearch because of Drupal. So rather than trying to make requests to both appliances, because we're still using Elasticsearch for a lot of other uses, especially for drawing, for like actually building the map itself. We didn't want to have to query both sets, and so we ultimately went with Elasticsearch. Their geo capabilities are really comparable to one another, though it could really easily be argued that Mongo is a lot more native, and so it works a little bit better. As for the store, I'm going to have to turn that over to Sean.
I got hooked because Amazon baited me. They gave me a free trial, and I'm like, oh, this is pretty easy. Barely any setup. It's very fast. It's very expandable. Great. And then on top of that, the way the query or the geo queries, you can do the fencing, you can do custom shapes. It's all just kind of built in, and it makes it really easy.
Cool, thank you.
And he asked about estimates on store. How long did that take? Do you not know how long it took? Are you allowed to talk about it?
I don't know.
Do any of our mobile people know how long it took?
I mean, I want to say, probably 3 guys, 6 months, something like that. Yeah, roughly.
Yeah, that sounds right.
Great investment.
Yeah.
The speed increase alone, definitely
It's
worth
a
it.
lot, yeah.
And
It's the candidness of sharing the evolution of all the different challenges you're up against.
Yeah. Do you have any other questions before we let you guys go? Yeah.
Did you do it in the example with Drupal 7 or Drupal 8?
we use D7
We're using 7 currently. Yeah. Yeah.
because the last one, I don't think it's supported on D8 yet, or if it is, it's
Yeah, it
not.
doesn't work
Not
on
great.
D8 yet as
Right.
well. Yeah, and also both of those projects were already 7 projects. So
And are you using the version 5 of Elasticsearch?
Yes.
yeah, so are
Yes.
we. Yeah.
5.5.
We recommend it if you can. It's really good.
Yeah.
Yes.
And just last question, did you use just the AWS for hosting? Because I saw that Elasticsearch has Elastic Cloud for hosting too, so I was wondering which one you're using or you're preferring.
For the USGS, it's internal.
Yeah, we have to do it internally because we're required.
Right, but for the NASA side, it's actually hosted on AWS. So we're already in the
They're
ecosystem.
using the cloud. Yeah.
Right.
Anything else?
How big is your Elastic cluster? What's your storage? For the internal one.
For the internal one, I think we're up to, we pushed it up to 90 gigs, and that handles the 3 indices. And for the NASA side, we were 3 servers, 3 shards, 2 replicas.
Yeah. I don't actually know how big ours is. Sorry. If anyone does, I don't think anyone here that would know. But no, I don't know how big the USGS one is. I'm sorry.
Lots of RAM as well.
16 gigs of RAM.
You think it's
Yeah.
16?
And it doesn't actually hit that. So,
That's interesting.
Cool. Thank you guys for coming.
thank you.
Appreciate it.
I do not have an extensive conversation with you guys
Okay.
because I was stuck on Metro.